like to introduce MP Diwakar, who is the Secretary for IEEE Com Society of Silicon Valley. Let's give him a big round of applause.
Thank you. Thank you. On behalf of IEEE, welcome. I'm glad you're all here. And it seems like the interest in the discussions that I saw earlier during networking tells me that this is a very good topic that you guys are most interested in and learning more, finding out the opportunities and things like that. So before I introduce our keynote speaker for session 1, let me take a moment to recognize other members of IEEE. Myself, MP Diwakar, I've been the secretary, sometimes program chair for the last 3-4 years. There is Samir Hirlekar in the back. He used to be a past officer, but right now he's a volunteer. And then Vishal Sharma, hiding here somewhere. He's another volunteer, and Samir specializes in, I think, motherboard SoCs for communication. Vishal is a specialist in data centers, and myself, data center fabric and sensor networks. When we put this program together, we recognize few gaps in the industry. And all of us have seen forecasts counting to 20 billion or 30 billion or even at $500 billion, depending on whom you believe, as the opportunity for Internet of Things. One thing is for sure, 2014 has turned out to be the year of IoT. It's gone from hype, all just talk, to real products and real implementations, and that's a great thing. It's a great beginning. So when we approached this, some of the gaps we recognized were, how do we make things that go into this sensor networks and Internet of Things, how do we make them cheaper? How do we design them faster? And what design tools do you use to make them, make the design flow go much quicker? Secondly, how do you do power management? How do you put a system together? Third, what about the brains behind this, the system on chip? The system on chip of yesterday and today don't work for this because they're over-designed, overburdened with power management. There has to be a new approach, to deal with them. So that has been the focus for session 1, after which we'll take a break and have dinner and more networking. And then session 2 is more on applications, where we look at applications in personal health, smart cities, vehicle-to-vehicle communication, and things like that. So stay tuned. There is going to be a lot of interesting material coming up. A couple of house rules. Please put your mobile to vibrate mode. Secondly, during the presentation, there is no Q&A. We are running a tight ship. There's absolutely no time because we have a chock full of speakers and programs to present. But we will have enough time for Q&A after the presentations end. So about 20-25 minutes in a panel format, which will be moderated. I will moderate session 1, and then Gene Wong will be moderating session 2. So with that, let me introduce the keynote speaker to start off. It is Sam Massey from InvenSense. Sam has been a veteran in the electronics hardware industry for over 18 years, and he's the director for product management of wearables at InvenSense. So without further delay, here is Sam.
Thanks, MP. So let's see. It worked. Okay. Good evening, everyone. My name's Sam Massey. I work at InvenSense. InvenSense is a MEMS SoC company. Well, our new branding is a sensor platform system solution company. We're doing a lot more than sensors. And I think you'll see that here in my presentation. And I hope I can relay how this really does apply to the IoT. What I'm going to begin with here is we've identified a few IoT. The IoT is a very big market. I'm not sure anyone really has a grasp or has their hands around it. We're a consumer company. We're based on quarter-to-quarter growth and profit, so we have to attack the big areas. And so what we've done is identify a few of what we think is the bigger areas and try to put our system solutions in this. So I identify 4 areas, and I'll deep dive into one of them, which I feel is probably the fastest growing and probably the most opportunity for revenue. Okay. Okay, I guess I have to introduce my company. InventSense, we've been around since 2003. We're a public company. We're a market leader in MEMS sensors. We have 80% Android phone penetration. We have really good friends over there in Korea. Most recently, the Cupertino company down here, there was a teardown, and we were in there as well. So we've done a good job on the mobile side. We're now attacking some other areas, namely things like OIS, optical image stabilization, using gyros to offset the jitter in your hand in a mobile phone application or an SLR application. And then I'm in charge of the wearable market. Okay. We're engaged with all the key companies. We should probably add the Cupertino company down here now. We are being introduced this year alone in a lot of cool products, all the gear platforms at Samsung, the wearable, the LG wearables, Oculus, different cameras. We're inside basketballs for training applications, InfoMotion, Shot Track are the user sensors to track a basketball. How many dribbles per minute? How many? What's the rotation of the ball when you release it? What's the path of the ball towards the basket? Things like that. Sports equipment, tennis rackets, helicopters, and obviously mobiles. So let's talk about the Internet of Things. One of the big areas we've identified is home automation and security. Okay, so the system architecture for this is really it's a home gateway box in your house, and it connects a lot of different devices to it through different air protocols, whether it's Zigbee or DECT or Wi-Fi. So there's a lot of products being available today. You know, we use DropCam to spy in on our nanny at home. Different plugs, lights, televisions, appliances. The Nest is a good example of this. And what they're doing is offering the owner of the home a tablet, or you download an app on that tablet, and you get to control all these different pieces of equipment in your home through the tablet. Okay, so this is a home automation and security. A different area of home automation is actually controlling these devices in your house. Well, this is really my passion, is with wearables. Okay, imagine walking into your house, into your living room, and you say, "TV on." Your TV comes on. It knows through the BLE connection that it's me. It brings up my favorite menu, maybe my favorite ESPN channel, and then I get to, choose something from the guide like this, change a channel like that. This is happening. We're working with companies, big OEMs, trying to make this enable this feature through the home. So the architecture here is most likely it's going to be this way, where the app, you download your Samsung TV app, or you download the Nest app, and you choose it, you open up that app, and then you control your iPhone or you control your Android phone, and it controls that equipment. That's how this protocol looks like it's going to shape out. This is all the IoT. And what the enabling technology and all this is sensors and algorithms. Okay, that's a common theme with InventSense. How do we get our sensors in there? How do we get algorithms in there to help our customers get to market faster? Another area, probably not as big, but definitely margin, is a track, trace, and sense area for the IoT. This is where in a warehouse like Amazon, you track the big pallets through the warehouse. You track a certain box through the warehouse. Did it fall? Our sensors can detect the orientation of that box. It could detect if there was if it fell. So you could check the contents. You can even attach this sensors and algorithms to the person. That person who goes around, I don't know what he's doing exactly. Maybe he's checking the inventory. Did he go through the appropriate path through the warehouse? This type of technology is based on pedestrian dead reckoning, PDR. And in fact, InventSense just bought a company in Calgary back in July called TPI, who has lots of patents, lots of IP in this area. So we're attacking this market. Obviously, the first market is going to be the mobile PDR solution. This is inside of a mall. When you're walking, obviously you don't have GPS, but your phone is going to know where you're at through this dead reckoning technology. So when you walk in front of Nordstrom's, Google's going to send you a coupon. You walk in front of Starbucks, Google's going to know you're there. So we're solving that problem for the mobile space. It's going to get applied to areas like this for track, trace, and sense. Tracking your pet with a connected collar, maybe a smaller market, but same opportunity, same technology. Another area for the IoT is industrial automation. I would say we're not focused on this now, but the usage case is clear. You connect these smart meters, you connect these machines in a factory to the IoT. You can manage them from far away. You know when they're getting worn out. You could replace things. You could be more efficient in your factory. That's pretty obvious. This last area, which I'm going to deep dive into, we call it the personal area network. There's a lot of wearable devices out there now. It's all about where the usage case on what part of the body, right? The most, I think 60% of the units being shipped is for the wrist. Okay, so that's where our solutions are focused on. But you could buy a smart helmet. They have toothbrushes now with a pretty cool app using our sensors where it tracks where you are in your mouth. And the app is for your child. So when he's brushing his teeth, they have these monsters on each tooth. So as the child goes over every tooth, the monster explodes or dies or something. What else? There's other, Thalmic Labs has this something you wear here around the arm, and you could actually control PowerPoint with gestures. That was a pretty cool product using our sensors. Same thing with the rings. A couple companies are doing gesture recognition with a ring. The Google Glass is using our products. So the idea here is all this connected, this personal area network, everything on your body, the mobile is the hub. You open up the app, you look at the analytics, you look at your updated data. All this data goes to the cloud. I'll talk a little bit about that in a second. Okay, so deep diving into this area. The wearable market is, I think it's here. This year kind of sputtered. Okay, I think people were expecting big things, lots of launches. I think Samsung released 5 or 6 watches or wrist-worn devices. LG probably 2 or 3. Other companies are making some big announcements this last quarter for the Christmas season. It sputtered a bit, I think, because everyone's waiting for that bar to be set. Everyone's kind of copying each other, changing the form factor. Let's count the steps. Let's count your sleep, or not count your sleep, but let's quantify the sleep quality of your sleep. No one's made that killer product yet, okay? So with Apple's announcement the other day, they're changing the game a bit. They're having fitness in there, which is good for us at InventSense, but they're also adding different usage cases for these watches, like the digital touch thing where you could quickly sketch something. This could be a new way of communicating. That's what they're hoping. They're trying to create a killer usage case. In fact, I'm pretty sure Apple hasn't opened up its kimono yet. I think there's a lot of other things that we're going to hear about early next year. They didn't talk about anything about the services that they're providing with this watch. That's not by accident. I'm pretty sure they don't want to give their competitors a 4 or 5 month head start on a new product definition. So this market will eventually catch on, I think. These are some areas where InventSense in particular has been successful in. I mentioned basketball, Google Glass, all the smartwatches being introduced using our Excel gyro compass products, head mount displays, rings, sports equipment. Let's talk about the business model. If we can understand the business model, this is how we attack this market at InventSense. If we can help our customer make more money in this market, and we're not just talking about selling hardware, we could become more of a valuable vendor. Okay, so let's understand their business model and let's choose where we want to participate. So we're InventSense, we're an SoC company, okay, system on a chip, sensor system on a chip company. We provide sensors to hardware that's worn on the person to collect data. This data is always being synchronized with the app that's always connected to the cloud, okay? And this is where the real money is made in this market, right? It's the services that you can provide the user based on their data, their particular data, okay? So we said to ourselves, well, let's focus here, meaning let's provide sensor platform system solutions that really add value to our customer's customer. Okay, let's hold that thought. Oops. And then let's also participate here in the cloud. Let's help our customer collect more valuable data. Okay, let's hold that thought as well. What's an example of a service? I see it with really small companies. I'm in a really unique position where I get to talk to the smallest company out there in this market to the biggest companies in the world in this market. And I'm not really sure that the big companies exactly know what they're doing yet. I think they're too big. The small guys I've seen have really good business models. I'm not sure they'll be successful because they're too small. They don't have enough funding. They don't have a brand name. But the idea is really good. So, there's these small companies. You could look them up. Genote, Tupelo is in Dubai. Genote is in France. What they're doing is interesting. They're selling hardware to all these different types of hardware, like a heart rate monitor, a scale, a pedometer, activity tracker, smartwatch. This is blood glucose meter. This is pressure meter, blood pressure meter. They're selling all this to the same customer. They either give it to them for free, really discounted. They either design it themselves. Most likely they're ODMing it and branding it. And what they're doing is collecting their customers' data. This is an example of the health service. They collect their data, but Tupelo or Genote is not an expert in analysis of health data, right? So what they're doing is creating partnerships with health insurance companies, with big doctor corporations. Like here we have Palo Alto Medical something or other. They create partnerships with them. They get the permission of their customer to give, these health insurance people their data, and then the health insurance people is providing services back down to that user. This is a really good model. And if you look at what the big guys are doing, they've created these clouds, these services, right? The Google Fit, the Apple Health Kit, Samsung Sammy, it's called. I can't remember Microsoft, but the other smaller guys actually have a head start on this. These guys today are only providing whether it's a pedometer or a smartwatch, but it's not far-fetched to see Apple start providing weight scales, just like Fitbit does with their branded as Apple, right? So this is an example of the service. So how are we different, right? There's a few MEMS sensor company out there. There's, I think there's not a lot of argument about InventSense being the leader. The big box companies are in this. We have Bosch, we have ST Micro, Maxim's getting into this game. How are we different? We're really good at InventSense at integrated multiple sensors on a single die. This is all based on the fab process that our founder patented at Global Foundries and TSMC, 10 plus years ago. We could integrate the wafer die, the MEMS die with the CMOS die, okay? And from that point moving forward, it's processed like a CMOS wafer. So really cheap, really good yield. What our competitors are doing, they're building, we call them skyscrapers. They're taking an accelerometer die with a CMOS for the accelerometer, wire bonding them together. Then taking the gyro MEMS with the CMOS for that gyro, wire bonding them together, then putting the 6-axis in a package, wire bonding them together. So, a 6-axis product from ST has over 50 wire bonds, okay? We have something like 4, 5, or 6, okay? So the less wire bonds, you have higher reliability, lower power, less noise. All this stuff helps our sensor performance beat our competitors. So we're really good at integrating multiple sensors in a single die. So we have today Excel Gyro, Excel gyro compass, 6 and 9 axis. We've already introduced a pressure sensor. It's coming out later this year. We'll have 10 axis in a single die. Calibration, sensor fusion. We add, this is a very unique thing to our strategy. We have basically it's a hardware accelerator, a DSP, integrated in our chip, where we do the basic sensor functionality so that you don't have to do it off system on your MCU. So this DMP thing on our device is doing sensor fusion, calibration. So coming out of our chip is literally the orientation of our device. Okay, the quaternion they call it, the Euler angle. This data is coming out of our chip on an I2C bus. Our competitors, they have to send raw sensor data to the MCU. And from there, they're telling you, good luck, use a third-party sensor fusion company or develop your own, okay? So these are some reasons why we're winning. And one of the more recent strategies we implemented with our new CEO 2 years ago is, hey guys, you came into our company's like, you know, if we keep selling sensors, the price is just going to erode over time, especially as we get into these big companies. Let's start providing system solutions. That was the key. That was the word he used a lot. And now we're doing that. We're providing activity recognition algorithms, gesture libraries, pedestrian navigation's coming up. We have a whole slew of system solutions that we're going to provide to our markets. So back to the wearable grail. This is not a religious lesson, but you know, this is what I feel is the perfect product. Okay, fitness tracking. Your wearable has to do this. If you're in a smartphone ecosystem player, you know, Sony, Samsung, LG, Apple, you have to have smartphone notifications. You have to track your health. This is obvious. All the smartwatches today are adding heart rate monitor. Next year, they're adding more biometric sensors. Wearable payments. I had this before actually Apple introduced their watch. I felt this was a really compelling usage case. IoT control. I actually had this is what I was talking about, using your wearable, not just to track your health or look at your text messages, but go in your home and control some of the IoT devices in your home. That's a strong usage case as well. Voice control. So, our job is not to tell our customers what to make. Obviously this is like the perfect product. I'm not sure anyone's going to actually do this. What we're doing is providing system solutions around all these areas based on our product sensors. And let's talk about one of the key system solutions that's available today. The Fitbit, Nikes, all the gear products, all they're doing is counting your steps. Okay. And I think over time we've seen that you see the reports, everyone buys a Fitbit, after 3 or 4 months, they stop using it because step count becomes dull, I think. It's not very compelling. So what we're doing is actually using our gyro sensor in combination with accelerometer and a very smart algorithm. We can actually detect if you're on a bike, if you're on the elliptical machine, if you're rowing, if you're boxing, if you're, we're introducing a product next month with all these, something like 10 or 12 activities that we can recognize. The whole idea is to track your fitness. Okay? And this is where I think we're helping our customers make a better cloud. This is really important. Where, today, the Nikes, the Fitbits, all they're doing is collecting your step count in some cloud out there. Not sure how valuable that is. Maybe they know when your shoe is worn out. Okay. But imagine now you have, really intimate data about your user. He's an avid gym rat. He goes to the gym 3 times a week. He goes swimming twice a week. This will really help you push better services down to the user. This is probably my most compelling slide when I meet big customers. This is where they're trying to get to because they understand the model. I think, maybe a year and a half ago, no one understood this, but now I think everyone understands where to make money in this personal area network IoT space. And then we have these products. It's a automatic activity recognition library that's available today. You put it on a wrist-worn device and it can detect these activities. And like I said, in the next, by the end of October, we're adding like 6 or 7 more activities. We actually didn't stop there with the algorithms and the sensors. We actually developed an in-house reference design for our customers where we call it a single unit of motion. It's a system with an MCU, a BLE, InvenSense motion sensors, a pressure sensor. What we're doing is actually put this on a wrist-worn thingy that we designed here. We put the algorithm on it. This is our demo platform for automatic activity recognition algorithms. Okay, but it's also being used as an IoT single unit of motion. You put this on if you're a clothing company. What we're offering, I should mention, we're giving away the schematics, Gerber's layout, BOM for this device. You could reproduce it, or we can actually push you towards a ODM in Taiwan who's building these for anybody, right? You negotiate a price, they'll build you 100,000. So what I see people doing is they're taking these, like a clothing company, they're putting them around the body, and they have an application for that. This is a basic building block for any IoT device, right? An MCU, a BLE, and sensors. So with that, I think I'm going to leave you with that thought. Okay. That's it. Thanks. Okay. So I'll switch you back.
Thank you. Our next speaker is from Qualcomm, Tarun Devan. He's the product manager for Internet of Things, and he works on SoCs, for Internet of Things.
So just regular. Okay. I just press next. Let's see. Okay. Escape. Oh, the other presentation.
Yeah.
Okay, I'll just introduce myself.
Yeah, go ahead. I'll
Okay,
load it up.
so my name is Tarun Devan. I work on the IoT space within Qualcomm. I'm pretty sure everybody's familiar with Qualcomm, so I don't have to introduce Qualcomm. Qualcomm's created an opportunity for some of us to start to look into the space, and been very fortunate to get an early view of what's going on in this space. Particularly, I work on the connectivity chipset at Qualcomm. But today, what I'm going to present to you is kind of a very broad view of how we at Qualcomm are looking at the Internet of Everything, and some of the problems that we're trying to address. So I think there's some technical problems, and there's a lot of business model related problems, and there's a bunch of stuff in between that needs to happen for this whole industry to be enabled. I think it was mentioned in this earlier presentation that one of the major challenges is that it's highly fragmented. If you look at it from a market perspective, there's so many different use cases, whether it be consumer products or industrial products. None of them have like a huge volume perspective. It's just you have to figure out which of the areas you want to attack and enable, and there's tons of challenges around it. So let me start to dig into this. It's this one, right? Okay, so there is, we all know, we have heard this, right? We're hoping by 2020, there's approximately 25 billion devices connected. I can just tell you a data point from my day-to-day job. I'm seeing it happen today. There's connected appliances that we're seeing getting connected. There's remote controllers. There is toys. I'm seeing it right in front of me. There's entrepreneurs who are coming to us and saying, we want to create this product category. And we're saying, what is that? And they're going, well, we're going to invent this, right? And they want us to enable them. So it is starting to happen right in front of our eyes. And it's really exciting moment, this 2014. So one of the key challenges, I think, for the Internet of Things is it's it's not about just the technology. I think I'm just going to keep reiterating that. I work on SoCs, right? That's why I'm here talking to you. But working on SoCs, what I realized it's not just a technical challenge. It's really looking at all the different industries and seeing what are the problems and the use cases they need us to solve, and how do we enable them, right? So let me dig into that a little bit. One of the first areas that we attacked is the connected home. So in the connected home, there's different connectivity technologies, whether it be Wi-Fi, Bluetooth, you name it, right? All the different connectivity technologies are there. So we're focused on enabling the connected home with the connectivity technologies. But we realized as we're getting the smart televisions to be connected over a 5 gigahertz Wi-Fi connection, right? Versus maybe a remote controller that's connected, right? What we realized is that all the OEMs and small companies, they're thinking of all these use cases that we never thought of. They're saying, I want to be able to walk into my front door, have a connected device in my wrist, and I want somebody in the house to know that I'm coming, or something to know that I'm coming, and I want that light to turn on if it's night, or I want that music to turn on when it's this time of the day. So all those use cases are being discussed and debated currently, and a lot of different companies want those things to come to reality and to fruition. So it's not just about the devices. That's the point I'm trying to make, right? It's not about the system on a chip technology that enables these low-cost devices. It's all about how do you enable these use cases, right? And that's the key challenge. So some of the challenges that we see are very fundamental. And if you look at it from a technical point of view, you'll say, oh, that's an easy problem to solve. But when you look at it from a practical point of view, it's not that easy. Let's talk about the first one, discover a device. So let's say you bring home a connected LED light into your home. You screw it on, something like this, right? And it's wall powered. It turns on. It has some sort of wireless connectivity. We don't have to talk about which one, but I work on Wi-Fi, so let's say it's Wi-Fi. It needs to get on the network. It's connected, right? It needs to somehow get on the network. How do you get it onto the network? Technically, if you think about it, it's a very simple problem to solve. But practically speaking, how do I know this is the one that needs to be on the network, right? What is the context here, right? This is my home. How does this, so I have to decide that this thing should get onto the network. Now, which network? I have actually multiple networks in my home. So which network does it get on? So when you think about how to implement, how things get onto a different, in a contextual, in an environment like a connected home, it's not that straightforward. One of the other challenges that we see is, let's say this device gets onto the network. What is it really capable of doing? And how do I or something else in the network know what it's capable of doing, right? Let's say this is a very simple soft white light. But then I put on another light there, which is multicolored, right? And it has certain properties to it. It has certain services to it, right? And it can advertise those services, and it can talk to the network, and then something in the network reacts to it, or somebody in the network reacts to it. Who controls the network, right? These are all interesting problems to solve. Adapt, contextually aware, proximally aware. Fancy words, I walk into the house with some sort of a device, and then suddenly the device leaves the house with somebody else. Is the device here or gone? Now, we understand the concept of locationing, but if it's a low-cost device, how do you do cost-effective locationing? And proximal local locationing. So what are the simple technologies that can give you an idea if something is within 100 meters or something is within 5 to 10 meters of where it needs to be, right? So here the technical challenge is, which is the right technical solution to apply there, right? It's not the most fanciest one, the most expensive one, right? The next one is, how do you actually manage these devices? Who manages these devices? Is it the smartphone? I work at Qualcomm, so the Qualcomm answer is it's the smartphone that manages all these devices, right? They got on the network, I have access to all these devices, and I can manage all these devices as I'm the master of all these devices, right? These are my devices. But then if you look at the industry has different perspective on this. I have these devices can get cloud connected, and I want to be able to do manageability through the cloud. And I go off. We have all heard of this, right? The whole Nest. If you're following the whole Nest thing, right? That whole video they have. I don't know if you have seen it, but if you haven't seen it, you should look it up on Google. You're approaching your house, your garage door opens, right? And everything happens seamlessly, right? So interoperability. So let me get a bit technical here. Interoperability. So a lot of these devices have to be extremely low cost. Okay, what does low cost imply? I can't have very memory intensive operating systems and protocols and even from the SoC perspective, expensive hardware, right? Integration onto the chip. Everything needs to be cheap, but it needs to create all these, and it needs to solve all these problems that I'm just talking about, right? So some of them may be RTOS-based, some may be Linux-based, God knows what they're based on, right? How do all these devices interop? I used to work on big networking devices in a past career. And now I'm looking at this and I'm going, wow, this is a more difficult problem than working on a big networking device, because I don't know how all these devices will interop with each other. There is no common language, right? And that's a big problem. There's no common networking language. There's no common application layer. There is no common cloud. Everything is fragmented, right? How do they exchange information, right? It comes back to the common language. And security. Now, 2014 is the year when we're starting to hear about security for IoT devices. Somebody breaks into the baby monitor, this and that, right? You must have heard some of those news items in the news. This is becoming a very hot topic. Whose IoT device is the most secure? And what does security mean? I think in the previous presentation, mobile payments was mentioned for wearable devices. What does that mean? It's mobile payments for wearable devices, way different than doing mobile payments for banking. Let me get into the SoC. For banking, you need secure elements. Those things, you can't even hack them physically, those secure elements, right? Do I need a secure element for a wearable device? Well, it's not cost effective. So what does mobile payment mean for a wearable device? So you need to solve that technical problem. You need to figure out exactly what your use cases are. What's really important and what's really important for that product category, right? So let me move on. So this is, I'm positioning a bit of what we sell at Qualcomm now. We have one of the solutions at Qualcomm in terms of connectivity, all these devices that don't talk the common language. This is all public. We have something called All Joint Services. It's a framework. It's a common language where different applications, whether it be sitting on a smartphone or anywhere else in any device, an application could be anywhere, right? It could be in a baby monitor, it could be in a smartphone. How all these devices can talk using the common language, and how can they advertise that I'm a 3-colored LED light versus a single-colored LED light, right? And this is how you should talk back to me, right? So Qualcomm is investing in helping to create a common framework for the industry. So there's different connectivity technologies. So first, things have to get connected before you even talk about data analytics in the cloud, right? Things are not connected. Now, sensors, we talked about sensors. Sensors connect, transmit, collect, analyze, aggregate and analyze, right? Before we even get to aggregate and analyze, we need to get things connected. So we're focused on, specifically, I'm focused on getting Wi-Fi to a state where we can have every single device that's Wi-Fi connected. We're not there today. We're partially there. We're starting to get different things connected using Wi-Fi. The ubiquity of Wi-Fi is the value. The ubiquity in terms of its ability to network over TCP, IP is the value, right? The challenge from an SoC perspective is how do you get it to be low cost, low power, and built in all these features that are enable and solve all these problems, right? And do it cost effectively, because all these devices may be cheap, right? So that's one of the problems. That's the key problem. So we expect Wi-Fi to evolve in the next few years, where everything from wearable devices to appliances which are wall powered will be connected using Wi-Fi. Bluetooth LE will have a place as well. We're not saying Wi-Fi is the only solution, but the ubiquity of Wi-Fi is going to have tremendous value into the industry. Okay, so this is a specific product that we worked on at Qualcomm. It's got a product name. I won't get much into the name, but what we have focused on is on power management. So I'm giving you a product perspective on the SoC now. We focused heavily on the power management. Let me explain to you what I mean by power management. It's actually very simple concept for these kind of devices. Most of the time, these devices are sleeping and playing dead. And you want them to be playing dead most of the time. And that's really what power management comes down to. And how much intelligence can you gather in the device while it's sleeping? What are the different sleep states, right? Okay, so let me give you an example. If I'm sleeping, is my processor in the SoC dead as well? What does sleep really mean, right? What can I do with the product, right, with the SoC when it's sleeping? So different sleep states. It's extremely important to understand that and tie to all those different applications that I was talking about, right, and all those different problems we're trying to we're trying to address. Obviously, we talked about the Wi-Fi ubiquity and the connectivity. We talked about all joint services. The integration of not just wireless connectivity, but the integration of connectivity from a networking point of view, right? And not just point-to-point connections, but really networking that you see in maybe an enterprise class product, right? Some of those features we're starting to really seep into these kind of devices. I've worked on networking and carrier grade devices, and I'm starting to see of how many of those things we can apply here. The innovation is the challenge and the opportunity. You have to do it in a very low memory footprint. These SoCs, they can't have too much memory. Memory costs, right? ROM, RAM, it's all cost, right? Processing power, it costs money, right? So how do you do? The innovation is how can you do this all in a very smart way while leaving memory for applications that can run on it, that makes it look and feel like a toy, right? For example, it gives it a personality to make it look and feel like an LED light, right? So the whole trend where we're seeing is an SoC that gets embedded in an LED light, for example, or a thermostat, for example, and that has the connectivity, the processing, the networking, the applications directly running on the SoC. And that's where the industry is heading. And that's what really focused on every day at Qualcomm, on how can we get the industry there in a fashion that they can build products and market products and sell products, and then we take them to the next cycle, right, of innovation. And this is the main challenge and opportunity for us from an SoC perspective. How do you get the sensor functionality, what I call the sensor hub, directly into the SoC? How do I get all the connectivity technologies directly into the SoC? How do I get the processor, right? Whether it be ARM, let's not get into that debate, right? How do I get all the processor into it? And how do I do it cost effectively, right? These are all interesting problems to solve and do it at the right cost point. That's the And I think we're heading in that direction. And I mean, this is going to be the key enabler for the Internet of Things, the SoC that enables devices to be smart and connected. Therefore, then we can talk about the big services play that everybody wants to talk about, right? There's money in services. Well, you can't have services unless these devices get connected. So then at that point, we can start talking about data analytics. We can start talking about the cloud. And all those different business models will come to fruition. So now I'm going full circle on my presentation. Remember, when I opened the presentation, I talked about it's not about just the technical challenges, which I just talked about. It's about the business models. I think once we solve the technical challenges and we enable the different product categories, we will enable all the services around IoE. Business models, TBD. Let the most brilliant entrepreneurs and most brilliant enterprises figure out what are the right business models. So that's all I had for you today. I appreciate your time and this opportunity. Thank you.
Thank you, Tarun. Next, we have Brandon Wong from Cadence. He's the group director for low power and 3D IC products. And he'll be talking about EDA, low power, 3D IC, and how to do them with EDA tools.
Well, this is fixing up. Let me talk about this. All the rosy picture around IoT. Great. Hundreds of startups. And these companies, the device company, provide a platform, a reference platform to lower the entry barrier for the startup. So that's good. We got a battlefield and the competition starts. Now, 5 years from now, 10 years from now, who will survive to become, the biggest IoT player? Besides the business model, it comes to the cost. How do you gonna define your system so that you will be cost competitive? That's gonna be the focus of my talk, is how to put things together cost effectively. So I'm gonna talk about how to do it in silicon design. So my topic will cover DEED. We'll talk about data and energy efficiency design in SoC. I'll cover a little bit my view of IoT, and I look at why IoT changed the silicon economics that we have been using in the last couple of decades. And I look at heterogeneous integration, exemplified by Invensys. And I look at computer architecture called layered cognition computing and why it is important for IoT. And I look at how you put all these pieces together in a very cost-effective way. And I'll give a 6 prediction for the IoT world. So as the previous speakers mentioned, IoT is really segmented. So IoT as a label, it doesn't really justify the diversity of all the things involved in that domain. There's a very low data rate sensing nodes like Invensys was mentioned. There's actually slightly higher data rate, smarter, and move to like Google Glass, which has a lot of image processing, and ultra-rich applications that requires very real-time and data intensive processing. And they all come at a different energy consumption and cost level. So IoT is really not a single segment as we see. And I kind of look at it here is that as we grow to the SoC design, it has the hub. It used to be the cloud computing. Now that your mobile device hub is become consolidated into a large, extremely scaled SoC. It's like MAMO. There's not many types of MAMO. Now, the leaf device that we call IoT leaf device is going to be like an inset. You're going to have many, many devices. They are segmented. They are specialized for their particular application. They are very, very low power, low energy efficiency. And you look at this number, that's how I look at here. Is the red color is where the IoT device is going to be. There's no single killer app. There's going to be zillion devices out there. And there's going to be the hub that more concentrated and consolidated into a SoC standard. So I'm going to move to say, hey, we move from standard product into SoC as mobile market we are in now. And that is really the Moore's law. Okay, we have bandwidth requirement, power, and complexity. Complexity is the key, that your SLCs gets more and more complicated. And what we do, semiconductor, is jump to the next node to accommodate the increase of capacity. And that scaling is hit the wall. More importantly, is IoT, if it really becomes the next wave, is going to lead us into different route. So it's not really about silicon processing scaling anymore, because the IoT device has all sorts of different nature, like MEMS, image sensors, photonics, a lot of RF different connectivities, non-volatile, all these power management, as our previous speakers mentioned, and they are not actually optimized to be manufactured in a single process, and not particularly do well in the deep submicron nodes. Now I look at the cost. This is the famous NVIDIA plot talk about per transistor cost as we move from mature node to advanced nodes. And you see the curve here is that when the node is introduced, the price is pretty high, and it's kind of stabilized, which is the flattened area. And if you compare the flattened, which is the cost per transistor, as we move from different process node, it always gets cheaper. And that's how it has been driven the whole semiconductor move forward until about now, 28 nanometer, the flattened area of each of the node is no longer bring you a cost benefit per transistor wise. And that leads to a reduce of design starts or tape out, whatever you call it. So because for the cost that we have, you really need $1 billion revenue in order to sponsor that type of SoC. And there were limited number of semiconductor company actually can do it. Like Qualcomm is one of them, but the number of design reduced. And that is not good for the new domain, which is IoT. We need a zillion different business model applications. How these two things gonna fit? What's the trend of the semi versus the diversity of application we're expecting for the next wave? We need heterogeneous integration, apparently. I'm gonna try to do just an example of what's gonna be in IoT. There's sensors and sensor bus and RF, wireless connectivities, low power analog flash could possibly for the higher end one. There's transceivers, power management, and of course you have the process system. Probably is very small in terms of silicon area. They're doing the control and DSP. So in a heterogeneous integration, you could possibly put them actually in two different die, means the different process nodes. And then you integrate them into a single package in a very cost-effective way. And that is what we call the 3D IC. Okay, appear to the end user, it is like a single IC package, like you buy the device from Invensys, a single device. But really, it's about put the different function in the best fit process node and integrate in a cost-effective way to serve the IoT market. And then I'm gonna move a little bit, switch to talk about how we're gonna do the low energy application that are required by IoT. And that is called layered cognition computing. I think Turan mentioned a little about different sleep mode. It is true that you actually need the system to be smart enough to understand which mode that you are in. For example, you have a nanowatt energy consumption in the deep sleep mode. And then you have some sort of trigger detecting things in your monitoring device. And then you move to a subsystem, do an event processing. And then you do a system level processing, which need pretty big power, like a typical mobile SoC, that processing that they consume in a couple hundred milliwatt to 1,000 milliwatt. And then you have the cloud server that consume larger than a watt. And that gets feedback to your Leaf device, which is a little IoT or wearable that you have. So the key here is that you have to design your SoC or your system in that different cognition layer in order to gain the energy efficiency. That's a little bit dive down to say what you're going to have in order to do that. There's a lot of technical details here, but in a high level, you need to define your system architecture. You need a software that works with the process configuration. You need a digital and analog co-design. You need a heterogeneous integration to have sensors, MEMS, and power management chip in a single package to lower the cost. And of course, you have system software integrate together. And these are the elements with putting together and able to do the SLC for the IoT. So this is one example that actually my group implemented using a 10 silica core. And so we look at the power consumption look very different as those that you're seeing in the mobile device that, usually we talk about 350 milliwatt for ARM quad core or something like that. This is we talk about microwatt. These are the device, little thing, the wearables that you don't have to change battery for a year. You don't need to charge it every night. So that shows that how you can adjust your operation voltage at different cognition layer, so that you will be able to save the energy, not necessarily power, by all these layers I talk about, the computing architectures, the design methodologies and things. I list a little bit detail the methodology we use in the right bottom corner about what kind of thing we used in order to achieve 1 microwatt dynamic power. This is not sleeping power. This is when the CPU actually is actively retreating device in the operation, active operation. So yeah, it's look very a lot of items, but that's really what need in IoT. You need a processor engine that tailored for this, I thought, the cognitive computing scheme instead of a regular general purpose core that's very energy efficiency. You have tons of interface that, including the Wi-Fi that Toran was mentioned, but there are potentially other more energy saving that you just have to mix together. So you have a strong vertical capability of putting them together. I mentioned a little bit in the MEMS integration and the 3D IC integration, but you surely need to support all these voltage regulation and ultra power design. You need a tool flow, of course, to put these things together, because each of the designer maybe only know a particular thing very well. Maybe I design sensor or I design something, but for IoT, you actually need to put the whole things together in a very cost-effective way. And of course, you have a manufacturing house to enable to do that. So that you got your reference board, you start your IoT design, you get into the market. But to survive the market, you need to be cost-effective, and that's what you need. You will ultimately, as the market becomes mature, the competition goes up, the survival will be the most cost-effective product. So I was in China. I saw this a company called Xiaomi, and they are selling the Fitbit. It was very similar as the Nike one for $9. I think it charged them $100. It's gone. It's just people charge a lot of premium, and that you can only see in the first year and two. How are you going to get to $9? That's the picture showing here. You need all these ingredient pieces together to create your unique SLC or 3D system, so that you ultimately win in a cost-effective when the market really scale. Okay, so that's my 6th prediction on IoT. Apparently, IoT is a word of the year for this year, but it will be ultimately replaced by a specific word based on the scale of the product. Okay, whether it's wearable or different segment, whoever. What killer app will come out is we'll wait to see. The SoC design that we currently everybody familiar is going to be branched into 2 distinct directions. One is still moving like the mobile SoC that you've been doing, very large, complex, and also a very special data intensive. I talk about the DEED, intensive, ultra low power. Branch, which is very specified to a particular application. It's not your general processor. So that's what I mean is that for IoT, the SoC will start with the design with a very single new insect that particularly serve the application you target at. And you need a cognitive layering to drive the Well, the funny thing is that you will actually be in sleep mode, but you have to appear to be always on. So we call about the leaf device is always on device, but you by define the computing architecture, you actually can be appear to be on, but have internal control. That's where the architecture differentiation come into play. And the good thing is that we've been worried about the death of the Moore's law for like the last at least 5 years. I think with IoT, we kind of really escape from that Moore's law, because now with IoT, we have an alternative path to integrate your system instead of go down to a process scaling with the cost, hierarchy when we go into next nodes. And the last one is kind of echo what Ying Wan Sensor was saying, the heterogeneous integration in silicon, whether you put multi-byte together or you put a monolithic 3D, anything that be able to integrate, they put different process for each, best fit for each of your application, but still appear to be integrated in a single device that will ultimately provide the cost-effective way. And that's where when there's 5,000 startup in the next 3 years in IoT, there's like 5 will survive, and because they were ultimately very cost-effective. That's it.
Thank you. The last speaker for session 1 today is Dev Bhattacharya. He is the Director of Hardware Engineering at Moog Crossbow. And he'll talk about how to put all of these components together and build a product.
Thanks to IEEE and TIE for arranging this one. And the previous speakers really talked about different kind of SoCs. And it's interesting to hear, like basically starting with Sam, Tarun, and Brandon, all of them talked about different SoCs, sensors, and how the combinations thing happens. So here, probably this will be a little boring. It's more of some technical and system design for end-to-end. It's not that like earlier speakers, it was all colorful charts and other kind of things. So, okay. So the topic is system design of multi-protocol IoT. And starting with, we'll look at what is Internet of Things, and then look at the capabilities and functions of IoT, and look at some of the architectural issues like end-to-end architecture, how it looks like, and then look at the IoT protocols. What are the protocols in IoT? And basically to divide the protocols into 2 levels. One is the application level protocols, which are key, and also go to the lower layer protocols, which might be interesting. And then look at the things that we talk about. What is things? So things level requirements, and things challenges, and conclusion. So, okay, the Internet of Things, I think I prepared it a little bit, vague. So, how do you go to the next one? Oh, okay, thank you. So the Internet means internet connectivity. That's a kind of simple one. Now, the things may provide all different kind of things. One is that it could be a very simple kind of RFID tags, which can provide the identification and information storage, whereas it could be information net collection, like a sensor networks, like combination of all the different kind of sensors. And it could be some information processing, so embedded edge processor, communication, control, and actuation kind of things. Think also, if we broadly define what it really goes inside, that could be an SoC, which can consist of different kind of transducers, which is maybe sensors or actuators. And also, it could be a MCU, which can have various different kind of processing capabilities. And my previous speakers also mentioned about it. Okay, I think, where is that? Okay, So capabilities and functions of IoT, it could be, that is what, some of the things we discussed earlier, that it could be a full capability as with the MCU and network, and where the key point in the full capability is that it runs on the device itself. It's just like an embedded system. And the next word is very important, that constrained. And that is what my previous speakers also spoke about, that constrained capability. And what is a constrained capability means? That means it could be MCU, it may not be MCU. It could be networking, it could be without networking. So it could be various kind of capabilities that could have. So what happens in case of the constrained capability is that the IoT application runs on the cloud or a server on the cloud. So the functions wise, it can be IO input or output that we know about. And okay. So here is a simplified IoT system architecture. And you can see that starting with what we have is a IoT level stuff, and then the internet, and then the user kind of a way to look at it. So as you see from the IoT side, there could be some like a hodgepodge IoT network, which have different constrained capabilities. And it could be a different kind of functionality, different kind of capability, and they all kind of bunch together and go through various other functions, and that connects to the internet gateway, to the internet cloud. So in a full capability IoT, you have the option to directly go to the internet cloud, or it can go through a IoT network. And here is the user level. There can be use a remote server, data analytics, or a smartphone to do the controls. Okay, what are the multiple protocols of IoT we are talking about? These are very simple way of representing the overall things. So excuse me for simplifying it too much. So the application level, there are HTTP REST, which everybody knows about, but because of the constraint capability, there are two new protocols came, which is MQTT and CoAP. And then there is a transport TCP UDP, everybody is aware of that. And this IPv6, everybody is aware of that. But there is a new thing came. Then when the IPv6 were not able to provide that 1500 bytes coming down, and as my previous speaker spoke about, that the memory has to be very small, right? So memory can be only accommodating very small number of bytes. So that is why the 6LoWPAN was configured that, okay, it can be a small 100 and couple of bytes, right? 130 or some number of bytes that you divide the IP 1500 byte chunk into different kind of chunks and allow the small memory to be there. And also here that UDP, look at the UDP point of view, like a TCP running on the memory will take a lot of state. TCP has a state, and those states have to be put in the memory. That may not be very good when you go to a lower capability. And there are a bunch of security, and in the wireless level, lower layer protocols is the wireless. This is actually MAC level and the lower level protocol, which are based on 802.15.4 and Wi-Fi and Bluetooth LE. But these are very simplified, and again, there is security for all the layers. So what are the application layer protocols and what it really means? So HTTP and REST, everybody knows about it. They are available everywhere. There is a backend processing ability, and but the problem is there is a message latencies, and the message latencies could be in seconds, and that could be as good for a home level thing, but it may not be good for certain other application that M2M and other thing we'll look at. So there are other protocols like MQTT and constrained application protocol, which came about to look at a constrained device requirement, so that a constrained device can run from all the way to the server. This particular protocol can run. So that will take a very small amount of footprint, what we talked about in the SoC and other cases. So MQTT is a very popular M2M lightweight protocol. It is a message oriented, and basically it is used for, started with a telemetry kind of a thing. It came from IBM. And then this is a constrained application protocol. This is like a HTTP REST has been kind of converted into a protocol where the number of bytes that are allowed are very small. So we are kind of constraining, again, in the constrained device, we cannot use that. And then what we are doing, this HTTP REST, look at again TCP, and here we are going for UDP level. So basically we don't want the TCP flows here because we cannot store that in the memory. So we want a smaller memory, a smaller footprint, and that is why we did that. And then lower layer protocols wise, if we look at a Wi-Fi and 802.15.4 and Bluetooth LE, and each has got its advantages and disadvantages. See, Wi-Fi wise, you can see that connection is very easy, that you know how to connect it. There are lots of software, lots of processes that are available, how to connect a Wi-Fi device to the Wi-Fi network, okay? But there are something like a higher cost and power. So, but it can be used in the burst mode and other kind of things. Their Wi-Fi power can come down, but the data transfer rate you see high. And there is a good thing about the security that you see WPA2 kind of encryption, where encrypts the network with a 256-bit key. None of the particular protocols you'll find a 256-bit key here. So if you look at the 802.15.4 is good for the sensor and the sensor related, where is a kind of a low power consumption. The range is a little lower, but there is a security which may not be that good, but the data transfer rate is 250 kilobit per second. Whereas the Bluetooth, it's a very long battery life and it can be kind of designed. That's why it has come into play for a lot of wearables and other kind of thing. And the range is 50 meter. It has got a 128-bit AES, and the data transfer is lower than 100 kilobit per second. So what are the things level requirement? One couple of things to look at. One is what are the functional modes? How we want to use this device? Is it a sensor, it is an actuator, or it is both sensor and actuator? And what is being sensed? Like what is the sensor resolution? What we want to do with that particular data? Do we want an accurate measurement or a quick measurement? And what is the measurement frequency? How often we want to read it? And how is the measurement triggered? It is by the timer or a particular external event or some other thing which is happening. And what kind of processing can be done on the sense data? As Sam talked about, that in InvenSense, they take the sense data, they process it, and give you a quaternion matrix so that it is very easy for the next level software to process it. But if you get raw data, you have to do that whole processing by yourself. Now the space available, how big of a sensor or actuator can be accommodated, how you power it. Is it a primary power battery or it is a secondary power battery with energy harvesting? So those are the things you have to consider. Then security requirement. So what kind of encryption you need? You need authorization. There are various levels of security. If I go through that, then it will take a couple of hours. Okay. So then connection to the internet. It is a direct or through internet gateway. And what kind of things we look at here? What is the data rate? What is the distance? And what is the latency? And then the cost. The cost is one thing we have to understand, the overall cost of a whole IoT deployment. And here, one thing I'm not talking about is the whole manageability of how everything is kind of, like SNMP, another kind of how it is managed, how it is, put in the system, how the system knows about it when it goes away and comes back. And this is with a mobile software. So it is a whole bunch of new things. If it is a fixed one, then you can actually detect how the thing goes away and comes back. But there is a lot of new things required to do that. So if we go back to the things, challenges, what are the challenges here? Number one, many people talked about it, is the power consumption. So how do you get the power consumption lower? So there are a couple of ways we can do it. One is the duty cycle. We need to know the system usage duty cycle. So how the system is being used. So if it is a very high bandwidth, then who is the culprit? Then the Wi-Fi is a culprit, right? We need to minimize the radio thing. But if it is mostly inactive as it is sleeping, then it could be the overall, the standby power needs to be optimized. So again, this is talking about the radio transceiver wise, and then the memory and MCU cost power consumption. So if we use a SoC with a small 64 kilobyte memory, then it's probably a good idea to use MQTT or COAP kind of thing. But you will not find a lot of different servers to use it, so you have to put that particular code yourself. There are, HTTP REST, you will find easily a server, Apache server can do it, but this requires some more work on your part to find a particular server. And then frequent interrupts. So another thing you have to think about the hardware level, software level, where the hardware and software kind of mix together. Those are the things like interrupt, how you poll the data, how you get the data, and other kind of things. So those are the things here how you have a FIFO and hub manage. If you look at a chip like InvenSense, they have done a lot of things, to get the data. You can get the data that they can sample it at a lot higher speed, but you can read at a much lower speed. So those are the kind of things that are there. And again, minimize the power consumption for higher power circuits. You have to determine who are the culprit in your thing. You don't want to put a bigger memory in your system, then it will be consuming a lot of power. So you want to use a flash, and then voltage, reference voltage, oscillators, and those are kind of small things which can cause power. So in order to do it, one of the things in the designing, of course, you can go to SoC and design the whole modular platform, a whole thing into the SoC. But when the SoCs are not available, you have to design system based on the pre-existing power optimized kind of chips. So that you can do. And the conclusion-wise, we just provided an overview and what is the full capability and constrained capability IoT. One of the key things is the word constrained that I want all of you to take home. That is the constrained capability. And when it is constrained, then the protocols and everything in the system, end-to-end system, has to be designed for the constrained one. Of course, you can say, I don't find it, I don't have a server to do that. That's a different thing. So the application layer and lower layer protocols are compared, and the main thing is that designing for IoT calls for a system design to match constrained capabilities of things. So basically, we have to design, because the things are constrained, we have to design it around that. The whole system has to be designed around that to meet the power, cost, and other targets. That's all.
Go ahead. Let me invite the first three speakers also to the stage, and we'll have a quick Q&A. Now we're running late, so I'm going to sacrifice my Q&A. Maybe I'll ask one or two, and then leave it up to the audience. Can I have Sam come up here? And Brandon? Well, they're getting settled down. A shout out to UC Davis. Stephanie, I'm not sure if you're here. Santa Clara University, I realize there are 3 students here. They were here earlier because they're very interested. Oh yeah, right there. Welcome, guys. I mean, these 3 guys are interested in doing an IoT startup, so we made a special invite for them. All right, so I hope we have a couple of volunteers with the mic to go around in the audience. Okay, to start off, Sam, what will make this wearable customers stay on and use it for a longer period of time? Have you looked into the freemium model to get them interested? And if that is the case, how do you manage the hardware, costs of such a freemium model?
Sorry, you're saying premium model?
No, freemium, free. Free, you give away the device.
Okay.
Freemium, not premium.
Premium.
I know you would like to hear premium, but
yeah, margin. So I think I mentioned it a little bit. The wearable market has not taken off. It's pretty obvious why. No one's made a compelling product. Everybody is copying one another, different form factor, improving battery life a little bit. It's just not compelling enough for anyone to keep it on for more than 3, 4, 5 months. I don't think this freemium model actually will do that as well. Getting a product that just counts my steps for free I'm going to have the same problem that I paid for the Fitbit for $150, right? It's the information is not valuable enough. It's all related to the usage case. It's all related to making it useful in my day-to-day life all day long. And that's what my holy grail was about. If you can have this thing tell my time, track my fitness, control the IoT in my house, make wearable payments, do this, do that, that's going to be what I feel the compelling reason to not just make a product for the Silicon Valley guy that has extra money to buy the Fitbit product, right? But to make it, to attack the wide market, to attack everybody in the world. It's all related to the usage case.
So Brandon had a question and also a comment. I really like the analogy that you used, different bugs and mosquitoes and all, but you left out the big ones like a behemoth. And there's one sitting right next to you. So the question is, based on what I've heard or what I've experienced with 3D IC and 2.5D IC for that matter, they are expensive. Today, they are not there yet, to justify a presence in the IoT market. So how do we really get there?
Well, I actually have a live example. Evensis is integrating multiple dies in a single package and do it very cost effectively. So I think we look at two stages of 3D IC. One is that a device with structured, kind of structured device like sensors and memories and FPGAs, is repetitive, and those that can be has already been done quite cost effectively. Now, the expensive 3D IC right now is people try to do the entire SoC in a 3D IC fashion. I think if you guys went to DAC in June, you realize this monolithic 3D that Qualcomm was described, the CTO was described. That's difficult because you basically talk about your clock tree, go to one die and go to second die, move back to another die. It's a total design methodology changes, and it also requires a foundry to manufacture in that fashion. So this is still to become. But I think unless you're doing a MAMO device, which is like Qualcomm's doing, the hub device, the server device, that you need a lot of computing power. That's why you have a huge DRAM stack on top of SoC, that type of thing that you need the second type of 3D IC I talk about. But for IoT, the system integration is already happening. The highest wafer level package that's shipping nowadays is Sony, and their image sensor is together in a single package with multiple there. So it is in production, not in it's already in massive production. That's why. Yes.
Do we have any audience questions?
Here. So. Okay, so the question is for Talon. When you mention about connectivity technologies for IoT, you only mention about Wi-Fi and the low power Bluetooth, but you didn't talk about L2.15.4. So is it the reason is because you are working on Wi-Fi? Oh, you don't believe on L2.15.4.
Okay, I think this is a conversation over beer. I think the industry is using, let's put some facts on the table, right? The industry is using 15.4. They put Zigbee over it, they put 6LoWPAN over it, do all kinds of things, right? Different products in the market, especially in the carrier space with managed products, managed services. It's all based on 15.4 and connectivity, right? So there's value in 15.4. But today, where we're focused on, for us, the pivot point is, we have access to Wi-Fi technologies, and then we do see Wi-Fi evolving to where it can get to the range and to a significant range. When I say range, what the reach is, right? 100 meters, 200 meters, and so on, a kilometer, right? How far can you get Wi-Fi connectivity and at what low power? So I think that's our innovation that we're focused on and building upon. But clearly, there is a position for 15.4 as well. So we don't want to get caught up in just one connectivity technology. The key is we have to deliver the SoC that has the right connectivities that are being demanded by, could be brand name OEMs, right? Or it could be small companies that we're hoping will become big companies in the near future.
So the question there was addressed about the freemium model for IoT, and like it seems like it's at early stages, and I certainly don't want it. Certain people do want to go out and actually quantify themselves, but it seems like you need to go after use cases in which there is a freemium model, for example, in healthcare and maybe very specific niches in which there's a high premium. By actually having this data, you can then have cost savings. So essentially speaking, it is a freemium model, but it's not actually someone else is paying for it, but you're actually reducing their cost. And that would seem to be a much more addressable market, because somebody who is old or elderly, and you can save them having a heart transplant or some other very high cost event, by actually monitoring certain things, or maybe they go into hospital and they're in a recovery phase, by actually having information in that post-recovery phase, or someone who's actually fit and healthy and has some sort of surgery, that sort of information is timely and useful for a limited time period. But I don't think people want to turn themselves into robots in which they're quantifying everything. It's not at the point in which there's enough sensors and connectivity to make it actually that trade-off and pain point worthwhile for that to actually happen. And I think that's part of the reason it hasn't happened. So I think addressing those specific pain points in the market that maybe you can have a cost saving and there's a reason to actually put it in there in the first place.
Comments?
Yeah. Was there a question in there? But I appreciate your point totally. I guess when I mentioned earlier about the freemium model won't work for, say, fitness tracker, Fitbit type products, I still hold true to that. If it's not doing anything for me besides counting steps, I'm not going to wear it. But what you're seeing, I see a lot of what you're describing in the healthcare, where people are built. Yeah. And I see it in the healthcare segment where they give wearables to the elderly. Fall detection is a big one. When the person falls, they get the equipment in the house for free. They get the wearable. It's a necklace. Sometimes it's a bracelet for free. But they're paying for that service per month, whatever, $30 a month or something. And if someone falls, it's detected, and there's an automatic phone call that goes to the ambulance or the hospital or something. So in this type of market, what do they call it? The razor model, where you give something for free and sell the service on top of that, is very applicable, and I totally agree with you. Another big area is children tracking in China. I don't know why it hasn't come here yet. If InventSense doesn't work out, there's a real opportunity in China where they value their children very highly in China, maybe because they only have a few, but they provide children trackers. They're GPS and GPRS-enabled watches where it's connected directly to the network. And the app with the dad or the mom, when the child goes away from a certain point, so many meters outside the school, they should be at school during this time, they get a notification. So there's a big company in China called Qihoo. They're an internet company. They have 400 million users. They're the number 2 internet company in China. And they provide this service. They give the equipment, not free, but for like $5 for the watch, the children watch. And they charge the parents something like $9 a month. So $9 a month times 400 million, most of that. It's a good business opportunity.
Hi, my question has to do with the latest acquisition by Google of, I think, Lift Labs or something, which is the Parkinson's disease spoon design. So I was wondering if Sam can comment on that. The other question was going to be on 3D chips, which was that is it a state of the art today that you can all do all kinds of integration, or there's a limitation? So those things I wanted to know. And the third thing is that it would appear from a technology challenge, all of your discussions seem to indicate that the technology challenge has been met with all join and then Sam's chip in the marketplace, etc. So I just wanted to see if you believe that the technology challenge is largely met, or there are some holes and pockets there.
I'll answer the 3D questions. There's definitely a platform. A lot of people think 3D is riskier than you're doing the SoC. It is true for the mature market, like a mobile market. You already have the market at certain low cost level why you want to switch. Unless for power, again, so there's a leading company are moving towards 3D, but not for the cost, but for the power consumption. Now the IoT create a new segment that makes the 3D a better fit. One is that if you are, the company are much smaller doing IoT design. So let's say I'm a startup. First, I'm going to go get a reference board. I'm going to just write software. As you scale, you said this is not cost effective. You look at the board you're going to need to buy. So now you start looking at, say, how am I going to integrate things together? You look at, there's already a known good die for memory, for sensors out there. So you don't want to reinvent those in the SoC. Because by the nature of the IoT design is there's so many different elements in your system. They are different nature. Even though that you can have a team, let's say even a company like Qualcomm have all the talents. You have an expert in each of the areas, sensors, RF, and SoC, and you can design those at, let's say, 90% of successful rate. But when you come together, it's 0.9 times 0.9 times 0.9 times 0.9. So your SoC come out with somewhere success rate of 25%. And that's ultimately going to fold it into a cost increase. And IoT is a particularly leaf device, have two distinct requirements. One is low cost, $5, good target. And I already seen the Xiaomi came out with the Fitbit at $9. So the $150 Fitbit out of the window very soon. The second one is power consumption. And the good thing is that these reducing risk, reducing fundamental cost after scale. Okay, it's not your first try in 3D, when you have million shipment. The reducing cost, reducing risk, and lower entry barrier is where I think that a couple of years from now, it should be good differentiation among all the startups.
I can take up the technology level challenge. It seems to every time you see that, okay, technology has been met, but it is all evolving. As you see the low pan, why the low pan came, IP6 adaptation layer. The reason is that we did not want to have more memory, right? So, but how many places you can get a 6 low pan kind of stack if you want? How many places you can get a CoAP protocol with the request response? You will not get that, right? You might have to use the Apache protocol with a REST and TCP. So it is a long way to really implement the small footprint and other kind of low cost kind of things we are talking about. So.
With that, I think we had to stop. I know we're running late. So join me in thanking the panel for an excellent first half. So the dinner is back there and, parallel lines, both sides. Thank you.